Thank you, folks, for coming to this talk. We'll go ahead and get started. This talk is about using Blob Storage to build cloud-native applications and how data-centric applications are really enhanced by using Blob Storage, and we'll talk about all of the new features we've built. I have my colleagues Michael and Serjan here. We're going to do a combination of talking, but mostly demoing and building an app to go with this talk. So we're going to start off with a very brief introduction to Azure Storage Services and Blob Storage. However, we're not really going to get into a lot of detail there. The assumption, how many of you use Blob Storage today? Okay, great. So yeah, this is definitely the right talk in the sense that we're not going to go into any details on the basic service itself. What we're going to do instead is talk about building modern web apps with Blob Storage. We're going to build a rich JavaScript app using the JavaScript SDK for Blob Storage and being served from Blob Storage. We're then going to take that app and add a bunch of AI service usage to it in a serverless computing architecture to kind of make this app really scale well without really running your own infrastructure. There's another talk tomorrow afternoon, which is sort of the more traditional, here's all the features for Blob Storage and files and disks. So if that was the talk you were looking for, which we pretty much do one of those every build, that talk is tomorrow, 3 p.m. to 4 p.m. In a slightly more convenient location. And if you're looking for background on Blob Storage, if you're like, hey, I wanted to learn more about it, I've listed the last 3 years worth of talks, which you actually have more of a sequence from overview of all of the services into a deep dive into Blob Storage and into using Blob Storage for big data services. So let's kind of get started, talk a little bit about storage and Blob Storage, as I said just briefly. As you all know probably, we have 3 main services that handle unstructured data. We have disks, which are persistent disks for your Azure VMs. So if you're running any Azure VM with your boot disk or attach a data disk, you're using Azure disks. We're not going to really spend any time on that today's talk. We also have file storage, and that's our SMB as a service offering. So if you have applications that still require the SMB protocol and require reading and writing to files, even though it's a cloud service, files is the right service for you. We'll spend a good amount of time in tomorrow's talk on the file storage service. But the focus of the talk today is really around our object storage service, which is Azure Blob Storage. As you all know, again, it is our secure, highly scalable storage system for all forms of unstructured data, but you are coding to it with a REST API, either with our SDKs or directly over REST. In addition to these 3 services, we have data transport services to get data in and out of these services. So we have the disk import-export that we've had for a while. We also have our Azure Data Box service that allows you to move hundreds of terabytes or more to and from our data center. So the device is a small, like 50-pound box that can transport 100 terabytes of data at a time. In addition, we have a number of hybrid storage services. Azure File Sync is one of them that's coupled tightly with the Azure File Service, and we will talk about it tomorrow. Azure Store Simple, as well as something that we've had in market for a while. And a more recent acquisition is the Azure storage system, either physical or virtual filers, and that's a way to get Cloud NAS, an NFS endpoint in front of Blob Storage, or use it for burst computation by pulling in data into that namespace from an on-premise NetApp or Isilon or Windows File Server. So that's something we're going to be building more on, but we won't really focus on that in this talk. So let's dive into blobs. Blobs are Microsoft's durability layer, right? Every single Microsoft service that you use today, whether it be Office 365, Skype for Business, Teams, or on the consumer side, OneDrive, Skype, Xbox, they all use Blob Storage for their data persistence layer. So it's a massive scale service, trillions of objects, millions of transactions a second, and it really kind of takes that scale, and all of these internal services use Blob Storage in exactly the same way that you do. The same REST API, the same SDKs. There's no internal API that we expose to our internal services. In addition, every Azure service, nearly every Azure service, has either a direct or an indirect dependency on Blob Storage. So either you'll see a way to get data in and out from that service, through, and using Blob Storage as a persistence layer or as a way station for transformation of data, or that service underneath the covers will actually be using Blob Storage and then present that data to you. So the ultimate source of truth for your data is usually Blob Storage. So you take something like Event Hubs, for instance, or the Azure IoT Suite. Underneath the covers, they persist all of that event data you're streaming in to Blob Storage, and then serve it up to you off of VMs and memory caches and all of that, of course. So that's why even if you're not using Blob Storage directly, it's interesting to know about what the service can do, because as you interoperate with all of these other services that make up the Azure platform, it's useful to know about the data persistence layer. So let's look at that modern web apps scenario that I said is the focus of this talk. A few broad trends that I'll point out. Obviously, no mystery to all of you that are in this transformation of what applications are going through. So first thing is applications are mobile, they're immersive, and they're much more media rich than they used to be. So they deal with a lot more data that you have to ship to and from usually a mobile device. And these native apps for mobile devices or web apps that you're building are quite data driven. Right? They're really shells for data you're bringing in from somewhere, and they're personalized, right? Even if you have just a few kilobytes or a few megabytes of data per user, you multiply that by tens of millions or hundreds of millions of users at web scale, and you're talking, petabytes to tens of petabytes of data that you have to manage, scale, and have a lot of bursty behavior as your app is used around the world 24/7. Apps, as you know, can get pretty viral overnight, right? I mean, a couple months ago, who knew about Fortnite and the revolution that that's causing in sort of the gaming area? So the apps that are built today, you have to be willing to deal with scale very, very quickly. And of course, while you're doing all of this, cost effectiveness is important. You can obviously massively over provision anything, but that's not a good way at the end of the day to run a business and make sure our apps are profitable. So Blob Storage can help with all of these. It can really help you build and host your applications with near infinite scalability and really just not having you do anything for your data scale, and we'll show that later in the talk. Do so with very, very low cost, especially with our new tiers of storage. And then using your platform and language of choice. And you'll see that in the talk today, where we spend a lot of time using JavaScript and Java and other languages. So what we're going to do for most of the rest of the talk is start by building a web app. We're going to start with a very simple static web page, build that into what looks more like a web app to you. We're going to deliver that app to your users from Blob Storage, and we'll talk about the new features we're adding to make that possible. We're going to use client-side JavaScript SDK for Azure Storage to make that web app a lot nicer. And then we're really going to spend time talking about how we enhance this web app with Azure's AI and data services. So if you're in the Scott Gu keynote this morning, he talked quite a bit about serverless and AI and how we're sort of making that story much better for your applications and for you as developers. And that really is reflected even in this fundamental data service of Blob Storage. So, and the last piece that we'll focus on is we'll do all of this without ever touching a virtual machine, right? We want to show you that, as the service has evolved over the years, we started out with, cloud services and virtual machines, but now we're in a world where you can go build these applications entirely on a containerized architecture or on a serverless architecture with functions, and that's exactly what we'll do in this talk. So enough of me talking. I'm going to turn it over to my colleague, Michael, who's going to start building that app and showing you what we can do.
All right, so thanks, Vamshi. As Vamshi mentioned, we're going to start with a really simple web page here. So if we take a look, I'm just looking at the code for our home page. This is HTML. And we'll notice here that we just have a couple of hard-coded images. So if we scroll on over, we'll see that the image sources are just static. So what does this web page look like? Let's go ahead and go live, take a look at it in the browser. So here we go. We just have 3 images, classic vanilla, very simple web page right here. All we can do is view an image, we see a cat, and that's about it. So of course, we want to host this application on Blob Storage, right? This is a local host. So the first thing that we're going to do is we're going to come on over to our storage account. And here we are. Click on that. And notice over here in the left navigation bar, we have a new option, and that is a static website. So let's click on that. We're going to enable it. And we see that we have 2 input fields that pop up. So the first one is the index document name. This is the name of the document that's going to be returned when you hit the root of your website or any directory. So the name of our document that I just showed you was index.html. OK. And then we also have a field here for error document path. So this is the document that's going to be returned when the blob service returns a 404 error. So instead of getting 404 blob not found, now you get to specify a custom error page that's going to be returned when you hit a page that's not found. So in our case, we'll call that 404.html. And we'll say save. So what I want to call out here is that we created this $web container. So when we configured static websites, we have a new container, $web. And this is where we're going to want to put our web assets. So now we need to go and upload our web assets to that container. To do that, I'm going to use Storage Explorer. And Storage Explorer is a tool that just went GA a few weeks ago to easily manage your blobs and other storage types. So all I need to do is just click on the files that I want to put in there, drag and drop, and it'll take a couple seconds to upload. And OK, great. So now let's come on over back to our browser, and we are going to click on AzureStorageDemos.com. So here's our website again. Notice that it's at a custom domain. So of course, with the static websites, you have the ability to add a custom domain to your website. You also have the ability to get SSL support for your custom domain with the Azure CDN. And so I want to call out here that there's no document being specified, right? We're getting returned the default index.html document. And then if I go and type a bunch of gibberish, find something that's not actually there, what happens, we get our custom error page. All right, so let's now switch back over to the slides and just kind of recap what we saw there. All right, so we saw the new static website support for Azure Blob Storage, inexpensive, simple, and scalable web hosting, default document, custom error document, and custom domain SSL support with the Azure CDN. And so this is public preview targeting June. You can actually go ahead and try this out now with the link that's up on the screen. So that's a link to the custom portal, giving you very early bits here. Excited to be able to share these with you. And of course, we welcome your feedback on the feature to Azure Storage Feedback at Microsoft.com. We also showed you Storage Explorer. So this went GA just a few weeks ago. It enables you to easily manage the contents of your storage account. And this is support for blobs, files, tables, queues, and Cosmos DB entities. It's a multi-platform tool. It works on Windows, Mac, and Linux. And you can go check it out at the link that's on the slide. So now I'm going to turn it over to Serdan, who's going to talk about making our web application a little bit richer with the power of the JavaScript SDK.
All right. Thank you, Michael. It's really exciting to see now there is a way to inexpensively host your website on Blob Storage. What I'm going to do right now, I'm going to switch to this demo machine here. Michael has built a static, simple website. It's a photo sharing application. We want to take that application and make a rich JavaScript-powered application. So what I want to do, switch to VS Code, our favorite code editor here. As you recall, he had hard-coded images here in the index.html. What I will do here, I will take a dependency on the storage JavaScript SDK and list these images from Blob Storage service dynamically using JavaScript. And to do this, we're going to use the list blobs API from the SDK. I want to call out the storage JavaScript SDK is open source. In fact, all of the storage SDKs are open source. You can find them on GitHub. You can fork them. You can contribute to them. You can talk to us even. We have a Slack channel here on the JavaScript SDK. We have released the JavaScript general available package just last week, so it's a nice coincidence. Let's go back to the index.html. I'm going to add the dependency here at the bottom. I have some code snippets already ready for this. Otherwise, we would be spending an entire night troubleshooting my typos. This is the storage JavaScript SDK. What we want to do now, switch to the app.js right here, where I have my jQuery script for viewing images on the browser. Before I do that, I want to show you right now in the Storage Explorer, this is the structure of our website. Inside images directory here, this is where we host the images, and we have 4 images. Michael was showing 3 of them. Let's switch back to the jQuery. I'm going to now initialize the storage SDK here. All right. Here's just the 5 lines of code. What I have here, basically, this is the storage REST API endpoint for Blob. This is $web is where we're hosting the static website. Images directory is what we're interested in. We're going to be listing images dynamically from there. And I'm going to use SAS token to authenticate with the service. SAS token is one of the 2 ways to authenticate with Blob Storage. It grants users delegated access for a limited time with limited scope. I'm initializing the Blob service using Blob URI and SAS token. I hope that's visible over there. All right. So now with this Blob service instance here, we can really run many of the storage operations very easily. What I want to do first, create a list blobs function. This list blobs function simply calls list blobs segmented with prefix API from the storage SDK. It is segmented because our list blobs API lists image objects in segments of up to 5,000 objects. Also with prefix because we're only interested in images directory here. Any object whose prefix is images is what we're going to show on the web UI. Once this succeeds, we're going to build that image cart you saw earlier. Oh, sorry about that. And then we're going to iterate over each blob and then show this on the screen dynamically. Of course, this is a function. We need to call this on the page load. All right. jQuery is ready. Let's go back to the browser and check this out now. All right, let me go back. So we're hosting this on the local host right now. As you see, I have 4 images showing up on the browser. This is all dynamically listed from the Blob service. All right, so since this is a photo sharing app, let's also give our users ability to upload their own images. I'm going to put on the right top here, I'm going to put a upload button. Let's switch back to VS Code. Index.html, I'm looking for top now bar here. All right here. I already have a button here to expand the menu on the left. Let's add another button with the ID upload file. So using the power of jQuery right now, we're going to bind to the events on this. Every time somebody chooses a file with this button, we're going to trigger upload function from the storage SDK. All right, here is the code snippet. So on the upload file element, whenever there's a change, we're going to trigger this function. First, we're going to update the UI, saying we're uploading the file. And then from the blob service instance we created earlier, we're going to trigger create blob API. Once this succeeds, we're going to update the UI, saying that this is done, and then refresh the screen, listing blobs again dynamically from blob service. Going back to the browser thankfully automatically updates. As you see, upload a new file here. Let's test it out. Going to my images directory here. Let's upload this one over here. As you see, the image has been uploaded. Switching back to Storage Explorer. Let's refresh. As you see, I'm not faking anything. Coffee.jpg is really here. All right, going back, I also have a delete button here. Let's make use of that too. Simply, we're going to bind to the click event on the delete button. Whenever there's a click event firing, we're going to call delete blob API from the SDK. Very simple. And then if it succeeds, we're going to refresh the screen one more time. All right. OK. I wasn't supposed to delete that one over there. Michael, do you think you can help me recover from this?
Yeah. So thankfully, about a month ago, we moved into public preview of a feature called Soft Delete that enables us to recover from our accidentally deleted or overwritten blobs. So we're going to come over and navigate into our storage account. So here we go. And let's take a look now, again, on the left navigation bar. And we will see this feature, Soft Delete. So let's click on it. Thankfully, we had it enabled, which means that we are going to be able to recover our data. And you'll see here there's also a retention policy, right? So it says 7 days. So that's the amount of time that we're going to be able to recover our soft deleted data. And you can configure that anywhere from 1 day to 365 days, so a year. So now let's go ahead and navigate into our blob storage. Go into the $web container. Come on over here to images. So see how there are only 4 images, and we need that 5th image. There's a new option here in the portal to show deleted blobs. So let's click on that. We'll see here that we have coffee.jpg is in a deleted state. All we need to do is 1 click to undelete that. It's now in an active state. So if we come back over now to our website, refresh it, we have our coffee back.
Thank you so much. You saved the day. All right. All right. So to recap, let me switch to the demo version here. Wow, to the slides. To recap, what we have done here, we basically took the simple static website and built a dynamic web app using our JavaScript SDK. JavaScript SDK is only one of the SDKs we have. We have from .NET to PHP to C++, many SDKs, publicly available, open source. And these SDKs really make it easy for you to run your applications on Blob Storage. And it makes it easy to upload, download images, objects. It makes it easy for you to build efficient applications, efficient and scalable applications. If you do not want to take a dependency on one of our SDKs, you can simply use the REST APIs directly. Uploading an object is very simple, just a simple put operation on the Blob URI with SAS token. Downloading is also very simple, just a get, simple get. We also talked to you about soft delete. Michael, why don't you talk about that?
Yeah, so the feature that enabled us to recover the accidentally deleted blob was soft delete. It also protects against overwrites. So you, as I mentioned, can configure soft deleted data to exist for anywhere from 1 day to 365 days. Overwritten blobs are stored as soft deleted snapshots. and it's fully compatible with your existing code. So what that means is you can just turn it on with the checkbox. Everything will continue to work as it did before, and now you can recover your data that is accidentally deleted or overwritten. It's in public preview now, and we're looking to GA that next month. In the future, we are working towards full object versioning support. So I'm going to turn it back over now to Vamshi to talk about serverless development on Azure.
Thanks, Michael. So, we've built that client-side app. We're using it, but we're not really using as much of the cloud as we'd like to, right? So that's where we want to talk about what's next for this app. What can we do that's more interesting, more complex, that we can't really do on your local machine. So I want to talk a little bit about this journey that we've been on as Azure from servers to serverless architectures. Serverless architectures are, of course, sort of the in thing now, and for good reason, because they really remove a lot of complexity of infrastructure from all of us as developers. So it's kind of a little bit of a amusing history thing I put together, where we started out with Azure, right? Back in the day, we actually launched Azure with a PaaS service called Cloud Service, right, or Cloud Services, and all the way back into February 2010, which was also the GA date of Azure. So we initially started out thinking 8 years ago, it's going to be a PaaS world. We quickly discovered IaaS was still very much a requirement. People still did a lot of running of VMs and doing things around it. So we launched VMs in 2012. We also built websites around the same time. It's what's now known as web apps or app service. Back then they were called Azure websites, and that made it really easy to host your web app and scale the number of VMs for your web app up and down dynamically and do all of the good stuff around that. We added a job orchestration service for your high-performance compute called Azure Batch in about 2015. Then we realized, hey, these VMs, people really need the ability to deploy lots of them with the same image, essentially be stateless VMs or do some configuration but have the same source image. So that was our VM scale sets launch in March 2016. And that's about when we started getting into an explosion of all these services in 2016. So we added VM scale sets. We added Service Fabric, also GA'd in 2016 for microservices and sort of stateful microservices. We added the Azure Container Service at the same time, because that's around the time that people are really starting that shift from virtual machines to Docker or Mesosphere or other things, and really moving their infrastructure from virtual machines to better utilization with containers. And later in that year, we launched Azure Functions, which was our first foray into serverless runtime, essentially, where you could trigger a piece of code to run without ever really invoking either virtual machine or a container. More recently, just a couple of weeks ago, we GA'd Azure Container Instances. If you haven't used it, it's a super cool service because it kind of brings some of that serverless goodness to the container service. You're no longer bootstrapping and running your own Kubernetes cluster or something and consuming virtual machines. You can just talk to our always running, highly scaled service and say, give me a few containers, for a long-lived amount of time, for a few seconds, it doesn't really matter. We bill you by the second. We spin up the container in seconds. It's a really great service, and we'll actually use it later in this demo. So as you can see, we've been sort of on this journey of a different, going from serverless, and I filled it in intentionally in sort of the date order to see that as we've kind of learned from you as our customers and you as our developers to come to build really and tell us what's state of the art, what problems you're running into, we've been sort of filling in this continuum. All along, Blob Storage has always been there as an object storage service. It also launched in GA in February 2010. And it's had these core pillars, architectural pillars around data scale, and really never, allowing you to scale and serve your data at web scale without ever really needing to do anything. And we've, gotten better at that over the years. We've added features over the years. But one of the things that we're starting to do now, and we're releasing features around this, some of which you've already seen, is really how do we evolve blob storage to work better with a serverless architecture, right? And one of the first things that we did when we looked at this last year and said, what are we going to do, what features are we going to ship, is building a serverless computing architecture that allows you to use data, specifically blob data, as a trigger. So all of these, serverless architectures have a pretty simple pattern, right? You have a trigger or an event. You have some kind of event router that listens to that trigger, and then it goes off and calls the serverless runtime. So pretty straightforward, right? In our world, what we did for blob storage was we added the ability to use create blob storage events. So now every time a blob is created or deleted, we actually create an event that you can send to our event router, which is Azure Event Grid, and then that can end up calling functions, logic apps, any web endpoint that you want us to call in a sort of a one-to-many pub-sub mechanism. This stuff is relatively recent, actually. It's about August of 2017 that we previewed this. We talked about it at Ignite last year, and we GA'd it in January. It's been phenomenally popular with developers as they look at this and say, hey, this starts to actually make sense, and I can use it and do what I need to do. Blob storage events specifically support, as I said, both creation and deletion. You can also set up filters. So the way you were looking at that images directory, you can kind of filter down to a subset of your blobs and set up different event triggers. And Event Grid, one of the really cool things about it versus other event routers is it does the one-to-many. So you can take a single blob landing on blob storage and not just trigger like a sequential pipeline, but you can trigger a one-to-many pipeline. You can call a function. You can go post something to a container that's listening for that post. You can drop a message into an Azure queue. You can do all of these at once. So you can take a number of different operations in parallel with that. So again, to kind of work those concepts in and show you what we're able to do with this app, let's go make this app better. Serjan?
All right, thank you, Vamshi. That's a great introduction to what we're going to do next. So far, we have built a web app, simple, right, using JavaScript. We're hosting it on Blob Storage. You hit that web page, you're able to upload an image, list images. Now let's make use of some of the technologies Vamshi has talked about and trigger some microservices in the backend. And in this case, I have built one microservice that I want to show you using Azure Functions. Let's go back to our portal. I'm going to switch to another resource group here. All right. So in this resource group, we're using a different storage account. The function I'm going to talk to you about is this function over there. What this function simply does, for a given blob URI, it calls cognitive services. And cognitive services downloads the blob and detects the objects. This blob is an image, actually. It detects the images and gives us a description. Let me just quickly show that, the code. Here on, let me go back, line 25 is where we're calling cognitive services, providing cognitive services a URI to the image. Cognitive services returns us a caption, a string as a description of that image. So we can make use of that microservice to power our web app, right? Every time somebody uploads an image, we can call cognitive services to figure out what's in the image and show that description of the image to the user on the web UI, right? So how do we trigger this then? As you may recall, Vamshi talked about Event Grid as a way to handle events. Storage events are sent to Event Grid, and Event Grid can use an Azure function as event handler and trigger this Azure function to run. Let's make use of that now. I'm going to click on Add Event Grid Subscription here and wire up the Event Grid so that uploaded images trigger this function. Let me call this my new images. Topic type here is the storage account. We want to only subscribe to the events in the storage account. Let me choose the subscription here, the resource group. our storage account, in this case, is static website demo 2. We do not want to subscribe to all events. As Vamshi mentioned, there are 2 events currently we support, blob deleted and blob created. We just want to listen to blob created events. And then we do not want to trigger this function every time somebody updates or edits the HTML page. We only focus on a filter for images. Let me just type the resource URI for the images. Blob services. By the way, this is all documented in docs.microsoft.com. Containers. Right, hitting create here. This takes a few seconds to get deployed. Let me switch to our web app. This time I'm going to hit the storage account here, over here. As you see, I have 3 images. Let me switch back. It's deploying. In the meantime, we have shown you all this, using this PC so far. Michael, why don't you show all of this on your iPhone? Is it working?
So let's go ahead and switch over to this display. And there we go. So I'm going to click on the static website. Sorry, not static anymore. This is now a dynamic website. But anyway, we can see it now on my iPhone, scrolling through the images. And I'm going to go ahead and upload a new file. So I'm going to take a photo. So everybody smile. We're going to see what the Skynet thinks of you all. All right, we'll use that photo. It's uploading. OK, so it says it's done. Here we go. It's starting to appear.
Refresh the page.
And so let's refresh now. And here we go. A group of people sitting in a chair in front of a crowd. I guess you're all sitting in one chair.
Not bad. All right. Thank you, Michael. Yeah. Most progressive web apps really, are used on mobile devices today, and our web app also works on the mobile device. Let's switch back to this demo machine over here. What I want to show you here, as you see, as soon as the image was uploaded, the function got triggered. This is the URI, and this is the caption returned from the function. Switching back to our demo here, I'm just going to try another file here quickly. This one I liked a lot. Right. A man in a wetsuit carrying a surfboard. Yeah, that's pretty cool too. All right. Let's switch back to the slides. So building this was really simple using storage events and event grid. To recap what we have done, we have configured an event grid that listened to events from the storage, blob storage. Every time somebody uploaded an image into the blob storage, it triggered a storage event. Through event grid, this triggered function to run, function called the cognitive services. Cognitive services analyzed the image, detecting the objects, gave us back caption as a string. We then stored this caption in blob storage as metadata. For those of you who don't know, metadatas are simple key value pairs that can be up to 8 kilobytes of data. What we did here, we stored the metadata on the image itself, and when we list it on the browser, we also showed the metadata as description as well. So this was really simple, but let's think about other scenarios. This is a web app for photo sharing. You can imagine that users may want to upload their videos too, right? But in the video case, it's the flow is a bit more complex. You may require multiple microservices to process the video. In the next section of this demo, I have created the video support in this web app. Let me just walk you through that. This will be in the separate account here. As you see, I still have image support. Going back to videos. Here we have a bunch of videos. This web app now supports videos. And as you see, we have some text under the videos that can be used as description. We have thumbnails for the videos. Let's play one of the videos here. What's cool here, we even have captions, subtitles. And in this case, I chose Japanese and English. So how we got all of this information using serverless apps on Azure? So what we have done here, basically, we used a similar Azure function to trigger Video Indexer API on Azure. Video Indexer API is really cool. It takes a video, analyzing video frame by frame, figuring out what is being talked about in the video. It recognizes brands, celebrities, people. It recognizes text you may see on the video. It does a speech-to-text conversion, giving us the subtitles that you see here. It gave us the thumbnails. It gave us the text. It's really cool, right? What we have also done here, the video we are watching here is actually a lower resolution video. So users are uploading their raw videos. These may be 4K, 8K. We do not want to be streaming these videos over the internet, right? That's just waste of bandwidth. So what we're doing, in a separate microservice, we're triggering FFmpeg to transcode down the videos. And we're doing this using Azure Container Instance, a Docker container, because it's a long-running operation. It's more suitable with the Docker containers. Let me go to the portal and show you how I have wired up all of this. I have a video resource group right here. Let me start with the functions. This is the functions. You're going to see 3 functions here. All right, so this call vision API is the one for images. We're still supporting images. Call video indexer API over here is the one that triggers the video indexer. So event create passes us the URI to the blob. And then we're taking that URI, appending a SAS token to the URI. We're sending it to video indexer API. Video indexer API, then the process is kicked off. Because it's a long-running operation, the function ends here. And that whenever video indexer API completes its job, it calls back another function I have created here called video indexer reply. I don't think this switch. Let me just go back. All right. So this is the one that takes the reply from the video indexer API. It first retrieves the VTTs. These are subtitles to the video. And then it also takes the video details that contains the description. It contains the thumbnail. And then we take all of this and upload back into Blob Storage. Let me show you where we're uploading in the Blob Storage. I'm going to go to my Storage Explorer. This is in a separate storage account. Let me just find that out. It was static website demo 3. Scrolling to our web container. As you see, I have now more directories than before. As we build microservices, we have more stuff to store in Blob Storage. Subtitles are stored under subtitles. We have thumbnails here, and the transcoded videos. As I mentioned, we're also transcoding videos down using a Docker container. Let me switch back to the VS Code and show you the Docker container as well. Here it is. It's a simple Java application. Okay. So what this Java application does, we're using a really cool new feature of Event Grid. Event Grid now can post a message into a queue. This is announced just today. Every time you have a new blob, now Event Grid can post a message into the queue. We're doing this because this is a long-running operation, and a Docker container is what is going to get triggered. And here, what Docker container does, it looks at the transcode worker queue. It retrieves the first message it sees. If there's no message, it sleeps for a second. From this message, it retrieves the URL to the blob, then downloads the video down to the container. Once downloaded, it simply calls transcode function I have written here. Let's go to that. This is a simple function. It shells out and calls ffmpeg to transcode it down. Once this is done, it's going to call upload APIs from the Blob Storage SDK here. Let me get to that here. Uploading back into the transcode directory. All of this happen in the backend, and then users are the videos they have uploaded, they will be able to see on the web page. Right? So let me switch to our slides. To recap what we have done here, we again made use of the storage events. A video gets uploaded to our website. That triggers the event grid through storage events. That triggered the function to run. We had, as you recall, 2 functions. One function was called. That function called the Azure Video Indexer. Azure Video Indexer downloaded the video, analyzing frame by frame, giving us back the subtitles, the thumbnails, the description of the video. We then stored all of this in Blob Storage again. In parallel to this event grid posted a message to a queue as well. This is a completely new functionality. It's great for long-running operations. In this case, the queue was consumed by an Azure container instance, a Docker container. This is cool because it's all serverless. You can look at the queue length. If the queue length is really high, you can spin up more containers, scaling your cluster. If the queue length is low enough, you can scale down. All right, so that was it. Now let's look at another use case. Your web app is getting bigger and bigger. You have more videos. Then how are the users need some kind of way to search through, browse through these videos? I will pass it to Michael to talk about that.
Yeah, thanks, Serjan. So in order to solve this problem and make our videos more discoverable and for folks who are browsing our website to find relevant content, we're going to add Azure Search. So let's go ahead and switch to this machine. So right now, I'm going to show you how to do that in the storage account. So we're going to come over to our search resource group, click on the storage account. And once again, in the left navigation bar, we're going to come to the Blob service, and we are going to see here the ability to add Azure Search. So let's click on that. So the first thing that we need to do is we need to pick a search service. So thankfully, we already have a search service provisioned. Of course, if you don't have a search service provisioned, you can go ahead and do that here. So we'll click on this one. The next thing we want to do is connect to our data source. So there are a number of options, but of course, this is a talk on Azure Blob Storage, so we're going to use Azure Blob Storage. Sure, we'll call it Blob Data Source. And I want to call out this field here, data to extract. So because these are videos that we're going to be indexing, we don't actually want to index the content, we just want to index the metadata. So despite our videos being large files, all we need to do is actually index the metadata for those files. So we select storage metadata only. We're going to find the relevant container. So here we go. Container web. We select it. OK, and then remember that we're hosting these video files in a virtual directory called videos. So we say videos. OK. So now the Azure Search Service samples our data. And we're going to now be presented with a number of options to define our search index. So what we see here is that the fields that Serjan was writing into, or that our function was writing into, caption, which is a blob metadata key, is now populated here. So we definitely want to make that retrievable, filterable, sortable, facetable, and searchable. These terms you can look up on the Azure Search docs. I won't go into depth about what each of them mean now. And we're going to select OK. The last thing we want to do is import our data. So we defined here a schedule on which the Azure indexer is going to run and index the data that has changed. So we'll say that happens hourly. We'll call it video indexer. OK. And we'll say OK. So now I'm going to show you what this looks like on our website. Here we go. We'll come over here. We'll see we have a new option to search. Say OK. So of course, we could return all of the videos. This is the trivial case. But maybe we want to search for a more interesting term. So how about build? So we'll see now that we get relevant videos returned to us. These videos happen to have the word build in the caption that the video indexer returned to us in the previous stage of this demo. So let's switch on over back to the slides and just recap what we did there. So we used Azure Search to enable the users of our website to discover the content that was relevant to them. So Azure Search is a search as a service offering, and it's great for developers to build rich search experiences. We manage the infrastructure for you, so you get the durability, the scale, the operations management of the cloud. And you also get all these rich search functionalities like geo search and others without needing to become a search expert yourself. And of course, the last step of the demo there was defining an indexer, which is when we go and actually sample the data to re-index it. And Azure Search will automate that for you as well. So the next thing I want to talk about here is a scenario that could happen to our website, is that one of the videos on our website goes viral. So we need to scale performance when that video goes viral. I'm a developer. I went to sleep. We didn't have time to put the Azure CDN in front of our website, but we want to make sure that our website stays up and that this video is served to our users. So let's switch on back. To demo this, I am going to use Kubernetes. So I'm running a number of different containers that are all sequentially reading from the same blob to simulate a lot of users reading or streaming one of our video files. So let's kick that off right now. This is called download new. OK, so while that's running, I want to look at the code that's actually running inside my Docker containers.
You had a problem there. You forgot the YAML.
Ah, yes. Thanks, Sir John. So here we go. So now we've kicked off the deployment. So now let's go ahead and come back to our favorite code editor. And we will look here and just look at program.java. So we just have an infinite loop here that is reading from the same blob. So here's the code to read from the blob, right up here. And what I want you to notice about this is actually the new Java SDK. So this is the V10 Java SDK, and I'm going to let Serjan talk a little bit more about it in the slides in a second. But we're using that to simulate the performance here. So let's make sure that's running. So that was created. While that spins up, I'm going to go ahead and come back to the slides and talk about blob performance. So here we go. So recently, we increased the size, the maximum size of a single block blob object from 25x, from 200 gigabytes all the way up to 5 terabytes. We also increased read and write throughput for a single object to scale all the way up to the storage account limits. So I'm going to discuss those in a second, but that can be as much as 100 Gbps on a single object, both read and write throughput. And then, we also made 50% improvements for small reads, or for reads on small block blobs, or small blobs. So at the per storage account level, previously we were at 500 terabytes capacity limit, 20K TPS, and either 20K or 20 or 30 Gbps, depending on the region that you were in. Currently, we're sitting at 5 petabytes maximum capacity, 50K TPS, and 50 Gbps, independent of what region you're in, read and write, so ingress and egress. In this calendar year, we are going towards 20 petabytes capacity in a single storage account, 100K TPS, and 100 Gbps ingress and egress. Yeah, so as I said before, with the improvements that we made to enable single object read and write throughput to scale up to account limits, that means 100 Gbps read and write throughput for a single object. So of course, to consume these metrics, we want to use the Azure metrics. So we've always had metrics, but recently, we now have integration with the Azure Monitor services. So this enables monitoring charts and alerts on metrics. It enables you to archive analytics data into a storage account or stream it into event hubs. And it's all with one integrated set of APIs. So to monitor and to get metrics on all your services, you can use the Azure Monitor SDKs instead of having disparate APIs for each of the different services. So this is GA now, and we're going to take a look at the metrics in a second to evaluate how the blob performance is doing. In the future, we plan to integrate diagnostic logs with the Azure Monitor service, and that is moving into a preview in the second half of this year. So let's go ahead and switch back over to the demo and see how that's doing. So we're going to come to our storage account. Here we go. Come to the performance dashboard. Click on our storage account. And we're going to come over here and click on metrics. So we'll select the blob service. We are going to select egress and look at the sum. Let's go over the last 30 minutes, the 1 minute level. Apply. So 940 gigabytes in a minute. So what does that actually mean, right? 940 divided by 60 to get the seconds, times by 8, 125 gigabits per second on a single blob right there. And then, of course, we have the ability to maintain this sort of throughput consistently. So if we come back to our metrics, we will look over the last 24 hours. Say OK. And so we'll notice I ran this actually last night to simulate exactly the viral video scenario, which is I went to sleep, video goes viral. Can the blob storage support this sort of workload? And so you'll see here we averaged around 700 gigabytes per minute, which is around 100 Gbps over the course of 6 hours. So switching now back to the slides. Right there, we just showed you the Azure metrics. And I'll let Serjan talk about the new Rearchitected storage SDK for Java.
Thank you, Michael. That was really impressive, 125 gigabits per second. That was huge. All right, so we use the new Rearchitected storage Java SDK in that container. And I'm really excited right now about this because we're now supporting asynchronous I/O in our Java SDK using RxNative. For those of you who are familiar with reactive programming model, I have a sample here in the new Java SDK. Now everything is asynchronous. Put blob operation returns you a single. You can subscribe to it, and then as you see here, whenever success is emitted, we're just returning success. Also, with this new SDK architecture, we're releasing service-specific libraries. Previously, if you downloaded storage SDK, it contained blob table queue file. It was a huge package. We heard from you, our users. Now we're releasing service-specific packages, like today we released the blob package. I'm really excited about this. If you want to try, you can go to our GitHub page. It's in a separate branch as a preview. but it's also available on Maven as well. Right. Now, let's go back to our web app we were building. We made it scalable. We powered it with microservices in the cloud. Let's now look at how to secure this web application. I'm really excited here again because we're announcing a new feature that is Azure Active Directory Authentication for Blob REST APIs. Prior to this, you had only two options to authenticate with Blob Storage. That was SaaS token and shared key credentials. Now you can grant users access to the Blob Storage. You can grant groups and service principals as well access to Blob Storage using Azure Active Directory and Azure RBAC. In this case, we're supporting Blob container level access and queue as well. This is currently, we haven't released this yet. It's going to be released in a few weeks. But I have a test account where I'm going to demonstrate this to you on this web app. All right. Let's switch back to the demo machine. All right. Going to that test account. All right. So this is the same web app we have used. This time it says you're not authorized to view this page because I haven't logged in yet. And this web page relies on the ADAL JavaScript library, Azure Active Directory JavaScript library to authenticate. Let me just expand the menu here. I have a login button. I'm just going to click on that. It redirects me to Active Directory. I'm just going to sign in. Now it has prompted the user consent screen. So this is the app we have built. It's asking me to access Azure Storage on behalf of me. Let's accept that. And this has just redirected to us back to the main page. It should list the blobs. Yes, took a second there. As you see, these blobs are, again, dynamically populated using the auth token we acquired from Azure Active Directory. That's really exciting. Please stay tuned. This feature will be released in a few weeks. All right, switch back to the slides. All right, I'm going to turn over to Michael again to talk about cost optimization on this web app we're building.
Great. So the last step here is we want to minimize our cost for the data that we're storing on Blob Storage. So let's see here. So Azure Storage has, for a while now, had both the hot and cool storage tiers, both online storage, milliseconds of latency. In December, we GA'd archive storage, which is offline storage, inexpensive for capacity, 15-hour SLA to get your data back, but extremely inexpensive storage. So we also introduced at that time, in December, a blob level tiering API. So this is called set blob tier. Individual blobs can move between different tiers all within the same storage account. So one storage account can have hot, cool, and archive data. Of course, you can, since December, you've been able to do this manually. But now, we are introducing data lifecycle management to automate this process. So this is policy-based data tiering and retention, support for Blob Storage and GPv2 accounts, and preview is coming soon. So I'm going to switch back again and just show you what that looks like. So here we go. We have the Azure portal. I'm going to click on our storage account. And over here in our set of options, come down to the blob service, and we'll see lifecycle management. So let's click on that. So we actually already have a lifecycle management policy already configured. The name of our policy is called videos. It's of type lifecycle. Scroll down. Here we go. So now, we also look at the rules of what this lifecycle policy is doing. So for objects that have a last modification date of greater than 30 days, we're going to tier them to cool storage. For objects that have LMT of greater than 90 days, we're going to move it to archive storage, which is, once again, the offline, inexpensive for capacity storage tier. And then after 7 years, we're going to go ahead and delete this data. So this is really important for our scenario here, because you remember we had raw video files, and while we don't want to actually go ahead and delete those files right away, no one is accessing those. On our website, folks are accessing the transcoded video files. So we want to keep the files around, but we want to age them out and move them to inexpensive storage tiers automatically. So this lifecycle policy enables us to do that. So one other thing that I want to show you, as you can imagine, this takes a little while to take effect, right? We have 30 days, 90 days, and 7 years. But I just want to show you really quickly, in our blobs, we can see, if we come into the web container, into our videos, we'll just see that we can have different blobs all within the same storage account, different storage tiers, some in cool, some in hot, and some in archive. All right, so switching back to the slides, just to quickly recap, we just went over the data lifecycle management, which is moving into preview very soon. So now I'm going to go ahead and turn it back over to Vamshi to provide a summary.
Great. Thank you, Michael. Thank you, Serjan. That was pretty awesome. That's the first time I've had a demo go without any issues, start to end. It's an awesome job, folks. So as you saw through this demo, you can really make Azure Blob Storage the core of building your cloud-native apps. You can build and host your web apps on Blob Storage. You get data persistence for all of that heavy data at very high scale, very low cost with the tiered data. You can process all of that data with our AI services and our data analytics services. And you can do all of that in a serverless architecture mode, so you're not paying lots of money for infrastructure that's sitting there idle. You can spin up and spin down things, or spin up and spin down your containers, or go use Azure Functions. So we've added a lot of new features in the last few months to make this really tie together and have this actually be possible. Certainly the static website support helps host those websites. Soft delete is a great useful dev feature when you're working with data. And then the storage events and event grid integration is the key that enables the whole serverless architecture, right? Having that work seamlessly end to end really allows us to do this. And of course, none of this would be possible if we didn't increase the scalability of our blob data and our accounts. So you can go, we used to say 60 megabytes per second per blob. Now you've seen 125 gigabits per second off of single objects. So that's a pretty cool feature. And easy to say, lots of work architecturally for us to get done as a service for our engineering team to accomplish that. The Azure AD authentication allows you to build secure applications now and use your AD credentials that all of you are used to. And lastly, of course, the blob storage tiers, archive storage, and lifecycle management helps you do this cost effectively. So hopefully this was a good talk and useful, and we've given you some ideas on how to go enhance your usage. Many of you said at the beginning that you're using blob storage. Hopefully you can look at these features and say, what can I integrate into my own applications? So we'll stop there, and we'll be happy to take questions. Please fill out evals. Those are super helpful for us to structure and change the content and make it better next time. This time they're actually doing prices, so you at least get to put your hat in the ring for a set of prices, I guess. So we'll stop there, take questions. If you want to come up to the mic or just yell out, I'll repeat the question for the recording. You had a question, sir?
I won't make you repeat. Can you hear me? Just a quick question on the soft delete. Is that only accessible through the portal, or is that actually exposed through the SDK?
Yeah, it's completely programmatic. So it can be turned on and off on the control plane, either code, PowerShell, portal. And then the actual deletion, undeletion of that data is programmatic as well on the data plane. So you can list your blobs. There's an extra flag now that says show deleted blobs as well, and it'll give you back the metadata that says, hey, this is a deleted object, and you can go ahead and undelete all of it without ever touching the portal.
And is that when it fires the delete event, when it gets moved to the soft delete storage?
No, that's a great question. Michael?
Yeah, so that's correct. So when you delete the blob, the delete event will be fired. We'll store it in a state that's in a soft deleted state, which according to your application, if they function as they did before, will be invisible. Of course, you can use new APIs to list it. But that delete event is going to be fired when you call the API to delete the blob.
Great.
Okay,
Thanks. All right.
Hi, I just wanted to understand how you're doing that upload speed test. The static website, where you were uploading those files from to get that throughput rate?
So that was a download test, is what we showed in terms of like pulling data down. Yeah. What Michael did was run a Kubernetes cluster that had about 80 VMs or so, about 500 containers spin up. So we had enough throughput, because we need enough source throughut on the test side on the harness to actually pull that data sufficiently quickly off of Blob Storage.
So when you're calling the upload data, is that using AZ copy under the covers, or is it some other technology to do the upload?
For the testing of upload or download?
Yeah. Upload. To get in the throughput, upload throughput, how are you?
Oh, I see. So we didn't actually demo upload throughput here. We'll actually probably talk about it tomorrow. We showed you download throughput. That's what but upload throughput or download throughput, we were just using the Java SDK to go do it. You can use AZ copy or whatever.
But is that in the Java SDK? Encoded the AZ copy CLI stuff?
No, so the AZ copy is built on top of the C#, the .NET SDK. Yeah. It's actually built on top of the core CLR SDK, so it's multi-platform. Yeah. But yeah, you can use any one of these tools. Okay. So it was functionally equivalent. You could have used AZ copy.
Okay.
Yeah, thanks.
Hi, I'm primarily a Linux developer.
Okay.
And so I'm interested in the Fuse plugin.
Oh, great.
Could you comment on how production ready you would consider that?
Great, thank you. The Fuse plugin is actually GA. Is that right?
Yes, yesterday we GA'd it, so it's production ready. We did a lot of stress tests. We also documented all this stress and perf tests on GitHub as well. You can just go and read. And a lot of internal services are depending on it, and from the telemetry, I see billions of requests right now. So thumbs up. As long as you're using in the restrictions we highlighted in the GitHub repo, you can go to production.
We encourage you to try it out, and that's why we kind of had a long testing period, took it to GA. If you run into issues, of course, we're always willing to listen and see what we can do to make it better. As Serjan called out, there are certain specific restrictions we do call out. As long as you stay within those guardrails, you're good.
Okay, thank you. And one more question.
Yeah.
So Blob Storage is getting better and better. If I don't want a POSIX HDFS compliant file system, why would I use ADLS?
Yeah, that's a great question. We're actually intentionally kind of staying away from that, talking about it at this conference.
Oh, okay.
But we will address that.
That's telling in and of itself, maybe, right?
Yeah, we will talk about it in a couple of months. We'll be ready to talk in quite good detail about what we're doing around both of the services. ADLS today is built on top of Blob Storage, so it can give you a sense of where we're going.
Okay, fair enough. Thanks. Yeah.
Hello, I'd like to ask a question about the soft delete. So when you delete it, I will still charge for the storage of it, of this deleted object?
That's a good question. The question is, when you delete the blob, do you get charged? Yes, because that data is still resident in your account, until the retention period expires and we expire the data, you're still charged for it as if the
data... If it was deleted from the hot tier, it remains on the hot tier from the charge. Yeah. Okay, if I want to restore my so-called soft deleted, is it necessary to be restored at the same location and same name, or can I restore it to some other name, some other place? Because it could be already a newer version, right, of it?
Yeah, it's Michael, you want to get that?
Yeah, so you first need to call the undelete API, which is what I demoed here. Then you can copy it out to anywhere you want to copy it out to.
Okay, so I restore somewhere else under a different name.
Yeah. Yes. It's always restored to the same location.
Okay, the last question about this crazy performance numbers that you demonstrated. When you talk about 60 megabytes per second, I can understand that hard drive, on-premise hard drive sitting on my box, yes, it can deliver, like if it's not SSD, it can deliver 100 megabytes per second. Right? How did you get these numbers? Because I know that there are some laws of physics, right? And you cannot just get gigabytes per second out of thin air, right?
Yeah, yeah.
So could you just give more?
No, definitely. And I think this is some of the work that, there's a lot of work been put into this. There's a couple of limits here that we're looking at. First, for the read case, which is what we showed you here, you can imagine, what we're doing underneath the covers is, we're storing it on a hard disk back cluster, essentially, right? Like all of blob storage. Then we have a layer of SSD cache that, as we observe data being a lot hotter, will proactively promote it into that SSD cache. From there, if you have this sort of scenario where you have a lot of machines kind of reading the same data over and over again, we'll detect that automatically and move it up into our in-memory caches on our front end. So at the limit, when you have lots of requests, we're just serving it off of essentially a memcached type thing, right? We're serving it off of a distributed in-memory cache across hundreds of servers, which is why you can get that sort of throughput.
But
right?
do you need specially provisions this kind of configuration?
Nope,
you need to pay specially for this going up?
We did it automatically for you. That's the beauty of it. You don't have
you don't need to purchase like SSD-backed
nope,
account.
You don't have to
like
purchase anything. That's
okay.
still going to bill you. It's going to bill you for data egress, of course, if you're going out of our data center.
Right.
But if you're staying in the data center as we did, that was a $0 bill for that egress test, other than the whatever amount of time, whatever few cents it cost us to store those 4 gigs for you.
But it also means that if somebody asks this data for the first time, you will not get this kind of performance, right?
That's correct.
You need to have really hot place, right?
Absolutely.
So many people coming to the same data, then it goes up and becomes faster and faster, right?
Yeah, that's absolutely correct. The very first cold read is subject to the laws of physics, as you mentioned.
Right.
It is sitting on hard drive somewhere. We've got to go fetch those pages. Even there, we try to do optimizations. If we see you accessing a large object, we'll do some read-aheads. We'll kind of speculatively say, yep, we know you're going to go get some data pages later. So we'll do tricks behind the scenes to not have everything be a cold read. But fundamentally, if it's completely aged out of our caching and mechanisms and everything, you are going to see that first request not be as performant.
Okay, thanks.
Great, thank you.
Are there any restrictions to this? Because it can be misused.
No, not really. I mean, our whole goal with this sort of performance scalability improvements is just use storage the way you've always used it. Right? In fact, we'll talk a little bit more in the talk tomorrow about the write throughput performance. That's an even harder problem to get right. But we've done a bunch of re-architecture on our side to make that work right. And you have to do a little bit more work there because you have to write the blocks in parallel across many threads and things like that. But beyond that, we really don't want to make this something where you have to twiddle a bunch of knobs and set a bunch of config options. Otherwise, it defeats the purpose of saying your data is infinitely scalable. Yeah.
So you've talked about the embedded searching within images. Are you talking about the EXIF data within the image, or are you talking about a file that is separate to search it? So for example, if you have a PDF document and you did OCRing on it and you put the text inside of it, am I able to search against that, or do I have to save a separate file?
That's a great question. So Azure Search has a number of different functionality built into it. We just showed you the indexing of the metadata on the blob. But let's say you have PDFs and documents and things like that. You can actually configure Azure Search to crack the PDF, do the extraction of the data, and make that searchable. So it has a very rich set of supported data types as well as what you can do with it, including things like semantic search and things to that effect. And now integration, newly announced at Build, integration to cognitive services. It can pass off for you that image automatically into the cognitive services, get something back and index it for you. So it's a pretty slick thing, but yeah, you can kind of wire this up the way you want. Both what we showed you was we've already extracted everything and put it in metadata, but you can have Azure Search do some of that extraction for you for data types that it understands.
And it's inside the Azure Search service, not a different service, right?
Correct. It's inside the Azure Search service.
Okay, thank you.
Yeah, thank you so much. We'll stop here. We'll be here for questions if you have any other questions. Thank you so much for coming to this talk. Please don't forget to fill out your evals, and we'll be happy to hang out here for as long as you want.